Hello everyone. So this is the video dealing with section 3, dealing with functions. And we're going to divide this into two parts. The first part will cover the basic definitions of functions and how to determine if the graph of a particular equation or curve represents the graph of a function. So before we begin, let's take a look. So we have a verbal definition, what of a function means right here, which we're not really focused on that, the relationship between the x variable, as you can see here on this example, and the y variable, right? What we are interested in is your understanding of a algebraic definition of what of a function is. So there's two ways that we can represent a function. You see here one format where on the left side of this equal sign, we have a variable y, and on the right, we have this expression 2x plus 5. So we say that this is a function, y, that's the name of the function, and the expression on the right side of the equal sign is the function definition. In addition of using the variable y, we can call a function by a variable name like f, parentheses, and the variable that appears on the right side, in this case, x. So we say that f of x is the function name, x being the independent variable that appears on the right side of the equal sign. And the expression that's on the right side, as you can see here, we call it the output, or we can call it the function definition. This is what the function will do. Once we know that, we can write the function definition as either y equals an expression or f of x equals an expression. The next thing we want to be able to do is, like on this example here, once we are given a function definition in the function name, we want to be able to evaluate the function at a particular value. So as you can see here, the function name is f parentheses x. When we say that we want to evaluate f of 6 or f at 6, it means that we want to replace the variable x with the value 6 and evaluate what the expression on the right is. And all of that has to be done in parentheses. So take a look at the solution as we have presented here on the video. The original expression is this. We are going to remove all of the x's, and where you see the x, you're going to put the parentheses. And inside of the parentheses, you're going to put the number 6 because that's what we want to evaluate. Obviously, these two steps are here. They don't need to be done every time. They're just here for instruction purposes. You can begin with step 3 right here. From this step down, we are going to evaluate according to PEMDAS, which means parentheses first, expressions, multiplication and division, whichever one appears first, and addition and subtraction, the AS. So we evaluate 6 squared, which is 36. We multiply multiplication, 36 times 2, which is 72. And then we have 72 plus 6 minus 7, which is 71. So the value of the function at x equals 6 is 71. So this is what we need to do. It's very basic, and I am going to go over 3 examples for you, which is problem 3.3, 3.5, and 3.6. So let's take a look at these examples. So here they are. So we want to evaluate this function, h of x, at the point x equals -2. So I am going to replace, we write h of -2 equals, and I am going to replace every x in parentheses with the -2, keeping the structure of the function intact. minus 2 times negative 2 plus 1. And at this point, after I make the substitution, all I have to do is evaluate according to PEMDAS. So we have to do this first. So negative 2 squared, which is negative 2 times negative 2 is 4. These two multiplication, negative 2 times negative 2 is also positive 4. And then I write the positive 1. Okay, so h of negative 2 equals. And then I only have to perform this operation. Obviously, 4 plus 4 plus 1, 9. And that's all you have to do. So this is function evaluation. So let's take a look at the more complicated one. I need to evaluate capital H at 4. So wherever I have x, I am going to replace with 4 in parentheses. So 2 parentheses 4 squared minus 4 plus 5 and 4 minus 3. Okay, so now we have a situation that we have a numerator and denominator. So we have to work on the numerator and denominator separately. Doesn't matter which order you do them. I'm going to do the denominator first because it's easy. So 4 minus 3, 1. And then I'm going to do PEMDAS on the numerator. So I have to do the 4 squared first. 4 squared is 16. Minus 4 plus 5. Then I have to do the 16 times 2. Notice that I cannot do anything else with the denominator, not only because it's 1, but because I need to have a final answer for the numerator. So 32 minus 4 plus 5 over 1. Okay. H of 4. So now I can do 32 minus 4, which is 28, plus 5, 33 over 1, or since it's over 1, I can just write 33. So function evaluation, H at 4. And the last one is a little bit of a different kind of evaluation where instead of evaluating at a single number, I am going to evaluate at 2 times A. The procedure is exactly the same. And we are going to replace X with 2A plus 2A minus 1. And the same thing holds. I have to apply PEMDAS, and I have to understand that in this case, the 2 gets squared and the A gets squared. So I have the 2 that's on the outside, and 2A squared is like 2A times 2A, which is 4A squared plus 2A minus 1. Now I do this multiplication, which is 8A squared plus 2A minus 1. Notice that when you have an expression, you have to check if your final expression can be simplified by combining like terms. In this case, we cannot. So this is the final answer for that particular problem. Okay, so this is evaluating expressions at a particular point. Not complicated, and we apply PEMDAS after making the substitution of the value, number, or expression in parentheses. Okay, so let's continue now. The other topic for this first video, first part of section 3, which is dealing with functions, is not graphing functions, but determine if the graph of an equation is the graph of a function. So this is very easy. You can read the details later, but I will focus primarily on the test itself. The test is called a vertical line test. Very, very easy. When you are given the graph of something, any graph, you're going to get a vertical line, as you see here, this dashed line, and you're going to go from left to right with this vertical line, and you're going to identify if the vertical line intersects the graph that you were given in more than one location. Like in this case, this vertical line intersects the graph in two spots. If it intersects in more than one point, the graph that you were given is not the graph of a function. That is as simple as that. So we'll take a look at these two examples or something similar that I have over here. And it's very, very simple. So I have these graphs, okay? And all that you would do is you get a vertical line to determine if this is a function, and you're gonna move this vertical line from left to right, noticing where the vertical line will intercept the graph. Notice that if I pass the vertical line, all of these locations only cross the graph only once. So this is a function. So is this one. Okay, this is also a function because the vertical line intersects the graph only in one location. No matter where you go, it's only one location. But look what happens with this one. Here, it intersects in one location. But as soon as I get to this point right here or somewhere near, I have one spot, two spot, and three spots. So because my vertical line intersected the graph at more than one point, we say that this is not a function. And the same thing goes for the graph that you see on the example. Let me see if I can do this. Something similar to this, for example. This is definitely not a function again, because my vertical line, whoops, try to do a straight vertical line. So here are my two spots. So this is also not a function. Okay, notice that in this case, I don't even need to go further. As soon as I identify two or more locations on the graph that the vertical line intersects, I stop it immediately and I define it as not a function. Okay, so these two topics are the beginning two topics of section 3, and we'll have the next two in the next video.